Okay, so now we've got another equation. We would consider this a simple kind of equation in as much as over the interval from 0 to 2 pi, we're looking for all the kind of values that might make this equation true. Our trouble here is that, algebraically speaking, there's really not a whole lot we can do. Adding cosine of x to either side doesn't really change the situation for us because there are no common factors, and setting it to 0 isn't going to help much either. So what should we do? Well, here's an unusual case, and sometimes it takes a little bit of work to come up with one of these. But one thing that we should note is that on the other side over here we have 1. If there were a way to get this equation equal to 0, we should try it out. And the way that we're going to get this equal to 0 is to square both sides. So let's try that here. I'm going to square both sides. We're going to take sine of x minus cosine of x. We're going to square that value, and we're going to set it equal to 1 squared. Now, how is this going to help us? In this case, we know that we just get 1 on the right-hand side. That's easy enough. What happens on the left-hand side? Well, multiplying sine of x minus cosine of x times itself is going to result in a couple of squares. And not only that, there'll be positive squares. How is that? Well, watch. Let's take our first term, of course. Sine of x times sine of x is the square of the sine of x. We're going to have minus sine of x times minus cosine of x, and negative cosine of x times sine of x. That's going to translate into 2 sine x times cosine of x. And then we're going to take negative cosine of x times negative cosine of x, and that's going to be plus cosine squared x, and all that's equal to 1. Now, the way this helps us is if we rearrange the terms one more time. We've got the square of the sine of x. So I'm going to gather all my squared terms up front, plus the square of the cosine of x, minus 2 times the sine of x times the cosine of x is equal to 1. And we think to ourselves, well, we do recognize this value right here. When we take a square of sine and add a square of cosine, we know we get 1. So in fact, our new equation is 1 minus 2 times the sine of x times cosine of x equaling 1. And the nice thing about this is if we subtract 1 from both sides, we get a new equation that might be a little bit easier to deal with. That is, the sine of x times the cosine of x is equal to 0. Well, actually, to make it equal to 0 completely, I should divide both sides by negative 2, and I find sine of x times cosine of x is equal to 0. Well, now that's going to give me 2 equations that I would be able to solve, right? Because the factors, any 2 factors multiplied by each other set equal to 0 means that either one factor is equal to 0, or solutions to the other factor equals 0. So what do? Well, sine of x, we've already worked through this one. We know that at x equals 0, we're going to get a sine of 0. And that also at x equals pi, we're going to get 0. How about this one, where cosine of x is equal to 0? Well, cosine of x is equal to 0 when x is equal to pi over 2, right? This is another quadrantial angle value. And that is also going to mean along the vertical axis, and 3 pi over 2 is another such solution. So does that mean we're done? Well, the problem is no, because we took an extra step right here. We squared both sides. Whenever you square both sides of an equation in order to get a result, it is always worth taking the time to check your work and see what happens. Do all these solutions work out, or would one of them give us an extraneous solution? Well, let's try it out. If we use 0, let's try 0. Does the sine of 0 minus the cosine of 0 equal positive 1? And the answer, unfortunately, is no, right? Because 0 minus 1 is not equal to positive 1. So x equals 0 is an extraneous solution. Extraneous is an extraneous answer. Would pi work? Well, let's try it out. At x equals pi, we know that the sine of pi minus the cosine of pi should equal 1. If it does, the sine of pi is 0, and we're going to be subtracting the cosine of pi, which we know to be negative 1. And yeah, sure enough, that's true, right? Therefore, x equals pi is a solution. X equals 0 is not. Let's check it again right here. We've got pi over 2, the sine of pi over 2, minus the cosine of pi over 2 should equal 1 if we're right. And of course, cosine of pi over 2 is 0, sine of pi over 2 is 1. 1 minus 0, yeah, that equals 1, sure enough. So that's a good answer right there, pi over 2. Let's think about that, 3 pi over 2. If we try to take the sine of 3 pi over 2, is it going to work when we subtract away the cosine of 3 pi over 2? Do we get 1? Well, the answer in this case is sadly no, because negative 1 minus 0 cannot equal positive 1, and so that is another extraneous solution right here. I'll just write it out this way, extraneous. Okay, so knowing that, we know that our solution set now has to be the set of x equals pi and 3 pi over 2. And so we're done.